So, hello everyone. It's an honour to be here. I'm really glad to be here. I'm looking forward to conversing with you all later and learning from you later in the day. Rob, as you just said, asked me to kind of give a diagnosis of how science is understanding the climate crisis that we're in. So I've done my best to put that together. So as Rob said, I'm an ecological scientist, a system scientist by training. I have done work in that field for a while and worked up in the Arctic. I've actually moved away from researching the climate itself, and instead I'm much more focused on social systems and how we can respond to this time. And so my current research is actually looking at social action and how we can understand that and how we can instigate that. When I was thinking about how to start this talk, I was thinking about how Buddhism has affected my own practice and how Buddhist thought has shaped my own thinking on this. And my mind instantly went to Joanna Macy, who's a Buddhist teacher, but also a lifelong activist for both peace and environmental issues. And one of the key messages that I've taken from her work is this. It's a quote that she said, "Don't be afraid of the anguish that you feel, or the anger or fear, because these responses arrive from the depth of your caring and the truth of your interconnectedness with all beings." And I think a lot of what I'm going to speak about today is going to be quite distressing. I find it distressing. There's a real horror to some of it. And my invitation to you today is to not push that away, but to honor it and to accept it and to think about how that works through you and what that then you want to do about that realization. So her book, Active Hope, where she develops some of these ideas, she talks about this process that's inspired by her teachings called the work that reconnects. And it goes through 4 different stages. And the first of those stages is to start with gratitude. And the gratitude can then hold us and nourish us so that we can go on and face the hard realities that we're confronting. And that's the second step, the honoring our pain. But from that, you can then go and look, and the third step is seeing with new eyes and looking for inspiration about how to take action. And that then leads us to the 4th step of going forth and taking action. So this talk is going to be starting in the first 2 steps. I'm going to start with some gratitude and then move on to looking at the issues, the pain of the world. But then hopefully for the rest of this conference, the discussion will very much focus on the second and then hopefully the 3rd and 4th parts. So it's very easy for me to tap into where I find gratitude. I grew up here in North Wales, in the Snowdonia. So this is the Ogwen Valley. I grew up right at the foot of the valley. You could actually see my parents' house in the trees at the bottom. And I was blessed to grow up there, and it really shaped how I see things and how I live in the world. And I became fascinated by the natural history of the valley. I became fascinated by its geology, and I spent a lot of time hiking the hills and sitting on top of them and contemplating how it all got there. And from that, there was a few things that I learned. One, the forces of nature that shaped that valley, and also the immense timescales over which it emerged and evolved. This valley was shaped over hundreds of millions of years. And when you're thinking about deep time, it really puts your life in perspective, doesn't it? But one of the things that I also was thinking when you're sitting on top of these mountains, it's a thought that always pops in my head when I get to a summit, is looking down and seeing all that life down below, all the trees, all the plants, all the soil and all the worms that are in the soil. And you just keep going down in your mind until you kind of go through the crust and you kind of have this picture of the earth as this active being. But also this notion that basically life is just this thin layer on the surface of the planet. And below that, it's boiling hot and everything's dead, right? And likewise, if you sat on top of these mountains and you're looking up into the sky, you have the notion that, yes, you've got birds flying over your head, and above that you might have some pollen and some bacteria, but you go very much further than that, and it's just cold, and it's dark, and it's dead. And to the best of our knowledge, we are the only place that we know in the universe that holds life on our planet. This was a photo taken by the Apollo astronauts as they first visited the moon. And what's so striking is not the moon, it's the Earth, right? The beautiful nature of the Earth, but also the deadness of the moon, right? The barren moon that there is. And in contrast is incredibly striking, I find. So this was taken around the same time. It's one of the first photos that we have of the completely of the planet. And I think this image, for a lot of people, changed the way that they think about the planet. It helped birth partly the environmental movement around the 1970s, this awareness of this planetary awareness. But more than that, it also sparked a revolution in science, a revolution towards Earth system theory and Earth system thinking. Not trying to study parts of the planet in isolation, but trying to connect those and understand them as a whole, like the oceans, the atmosphere. In fact, we have different kind of segments of that, right? So, we understand that they're all connected, but there's these subsystems. There's the oceans, and then the hydrocycle, there's the atmosphere and the climate. There's glaciers and the cryosphere and all the ice. There's the lithosphere, the rocks, so the tectonics, the geology, the erosion. But also key to all of this is the biosphere. It's life itself, which is interconnected with all of these parts and shapes them. And just to give you an example of that, we have a rainforest. It's one of my favorite examples, right? Because we have all of these billions of trees growing in this forest, each one growing, each one taking in carbon dioxide through its leaves, each one taking up nutrients from its roots, absorbing water, which then goes up through its stem and then evaporates through its leaves. And all that water coming up ultimately starts to form droplets and clouds. And you can see the mist forming in the trees, right? But over this vast scale of the Amazon basin, this changes the entire climate of the planet. You have huge amounts of water, billions and billions and billions of liters, coming up and recycling and keeping water in that system, nourishing all that life, and then transporting from there as well in huge atmospheric rivers all the way across South America, bringing rains to the plains further south. And all of that is being driven by life. Right? And this is a life that's evolved over billions of years through eons and eons and eons. So all these different stages, the Devonian, the Permian, the Cretaceous, the Jurassic, and so on, and all the different stages of that, from the unicellular life through to aquatic invertebrates, all the way through to the emergence of plants on land, and then insects, and then vertebrates on top of that, right? We went through dinosaurs, and then we got to the mammals, and then we got to the humans, and eventually we got to the very last part of this diagram, which is the Holocene, the last 10,000 years, which is this really unusual period of climatic stability, where this stability has actually given rise and allowed for human settlement, human agriculture, human civilization to emerge, because the conditions were just right. But we're leaving that period now. We're leaving the Holocene, and we're entering this new epoch that scientists are describing as the Anthropocene, the age of mankind. And it's completely different, right? So what we're seeing is huge changes, right? So we know about these socioeconomic trends, right? The huge growth in the world's population over the last few centuries, the huge growth in our economy, many times more. We've seen this huge increase in energy usage, in the building of large dams, water use, and so on. But all of that scale of the human enterprise and all of this activity is causing an impact on the planet. It's always having an impact, right? So the footprint of our enterprise is also growing exponentially. And so you see carbon dioxide levels, nitrous oxide levels, methane levels, all increasing exponentially in the atmosphere, and they're all powerful greenhouse gases that trap heat. So you're seeing the surface temperature of the planet going up. You're seeing ocean acidification increasing, and you're seeing tropical forests being lost. Right? And scientists, we call this the Great Acceleration. That over the last 200 years or so, especially from the 1950s onwards, there's been this just massively dramatic increase in all of these. It's happened in the lifetime of just one person, pretty much, most of this, right? And since humans started settling and building civilization, half of all the world's forests have been felled. 2/3 of all the longest rivers are now dammed. Many of them don't flow all the way to the oceans anymore. And aquatic organisms can't migrate up and down those rivers. We've got carbon dioxide concentrations in the atmosphere from burning fossil fuels, mining coal, oil, gas, burning them. That's increased the level of carbon dioxide in the atmosphere by 50% now. the nitrogen fixation has doubled. So the planet now, mankind, fixes as much nitrogen as all the world's natural processes do combined. And we use them as fertilizers, which then we use to grow vast monocultures of crops to feed ourselves. A third of all the world's fisheries are now classed as overfished, which is to say that we're taking more fish every year than can be replenished, and it's driving these fish populations towards collapse. And oceans are more acidic. They're about 40% more acidic than they were in pre-industrial times. And as a result, organisms like these marine snails that use calcium carbonate to make their shells, those shells degrade in acidic waters, and so it's massively harming these species. So what's happening is that we're exceeding many, many different planetary boundaries. This is a scientific assessment of 9 different planetary boundaries, and the green zone is basically showing you the safe operating space, as scientists call it, of the planet. It's basically the Holocene-like conditions that we've had for the last 10,000 years. And you can see on pretty much all of the ones that we can measure now, we're exceeding those thresholds by quite some way. We are outside the safe operating space. We're outside the planetary boundaries that we should set for ourselves. So the task really, I think, for us this century is how do we get back within those boundaries, right? How do we reduce the size of our impact on the planet? But there's another challenge, right? Which is this need to have a social foundation. And this is a diagram from Kate Raworth's work on donut economics, where she talks about the need to have a safe and just space for humanity. And inside the safe and just space, we're talking about the need for everyone to have access to food, water, healthcare, energy, jobs, and so on. So the task really is to balance those two things. How do we live within that space? And she calls that the donut. So her book is called Donut Economics. I really recommend it. Well, I'm going to focus on just one of those aspects and think about what would it take to get back inside the planetary boundary for climate change. And for that, I'm going to go back to talk about what is the climate crisis and why do we need to address it. So I'm going to start back in the valley where I grew up, because this is a glacial valley. It was shaped by glaciers in the last ice ages. And if I'd been climbing up on the hills 20,000 years ago, this is what it looks like today. I know all these mountains by heart, and I know their names, right? Evau, Glidivau, Lydir, Royal Gorch, and so on. If I was up on that same point of Penarrola Wen, looking out across there 20,000 years ago, it would have looked like this. It would have been this vast sea of ice with the summits of those mountains just peeking out as little islands in the glaciers. This ice sheet was part of a massive ice sheet that spanned all of Eurasia. And there were similar ice sheets in North America as well. And below that, there was then a tundra across most of Central Europe and France and places that we have today. And then below that, we had a coniferous forest across Spain and Italy and Greece, which we now think of as in the taiga forests, boreal forests of Siberia and Canada. The key thing to understand is that those ice ages, the average temperature of the planet at the peak of that last ice age was only about 4 to 5 degrees colder than it was in pre-industrial times. It sounds like a tiny amount, 4 to 5 degrees, but it made that huge change to the surface of the planet. You can see here that these are showing the last 4 ice ages. Each ice age cycle takes about 100,000 years. You go from interglacial down and cool down and over a long period of time till you reach the glacial maximum. You can also see the CO2 that goes along with that, right? It's the CO2 that we know scientifically is driving that change in temperature. And so as the CO2 levels changed in the planet, we saw a corresponding change with the CO2. You can see at the very end of the red line, the temperature curve, the last 10,000 years, that really unusual period of stability. And you can also see on the blue line, the huge increase in CO2 relative to the background rate, right? Unlike anything that we've seen. We've now actually gone past 420 parts per million in the last couple of years. And as a result, the temperature of the planet's reaching record levels year after year. Last 2 years have broken records. This year looks like it's going to be a record-breaking year as well, potentially. And it's exactly what we should expect because we keep putting CO2 in the atmosphere, right? But as a result of the increasing temperatures, we're seeing all sorts of extreme weather events becoming much, much more severe, much more widespread, much more deadly. So deadly heat waves around the world. We're seeing the heat leading to catastrophic wildfires burning through people's towns. We're seeing the energy from the heat was also driving storms, makes the storms more powerful. Scientists have had to start introducing a new category for hurricanes. They're now category 6 hurricanes because they're so much more destructive. This is an example from the Caribbean. This is an example from my village in South Wales, where I live. My neighbours were flooded out of their homes because we had record-breaking rainfall, twice the normal amount for the month. Rivers couldn't take it, and people lost their homes and livelihoods. Sea levels are also rising around the world because as glaciers melt, seas rise, and that's again causing erosion and displacement of many coastal populations. And perhaps most significantly of all is the effect it's having on food supplies. And so we're seeing increasing droughts, and all the floods and all the other impacts that I showed you. They affect our harvests. And so there's increasing concerns about food supplies for the world and the risks of famines emerging again, especially if we had multiple bread baskets having simultaneous extreme weather events that could cause a cascade that would spread throughout society. I'm just going to say one more thing on this to kind of summarize it. And this for me is perhaps the most shocking of all and where we're headed, right? So this map is showing you the temperature of the planet, the black areas on the map, which represent only 0.8% of the Earth's surface, are where there's a mean annual temperature of over 29 degrees Celsius. Now, if we carry on warming the planet to 3 degrees, which is what we're currently on track to do by the end of this century, then these will be the areas of the planet where the mean annual temperature is over 29 degrees. These are temperatures that are scientists class as inhospitable to human life, right? So that's 3 billion people will be affected by that. Huge parts of India, Southeast Asia, and so on. Right? That's the scale that we're talking about. So climate change has been described as variously the biggest human rights issue of the 21st century, the greatest environmental threat humanity's ever faced, the biggest global health threat of the 21st century, the single greatest threat to sustainable development, and so on, right? It's not one of these things, right? It affects all our lives in all these aspects. And so it's all of these things. So the Intergovernmental Panel on Climate Change, when they published their last report a couple of years ago, Antonio Guterres, the UN Secretary General, said this. So the Intergovernmental Panel is the body of scientists, I should have said, sorry, who summarize all of this climate science, right? They said, this report today is a code red for humanity. The alarm bells are deafening and the evidence is irrefutable. Greenhouse gas emissions from burning fossil fuels and deforestation are choking our planet and putting billions of people at immediate risk. Global heating is affecting every region on Earth, with many of the changes becoming irreversible. Billions of people he's talking about. Scientists have been trying to sound the alarm on this again and again. We're now, putting out statements like this, declarations where we're saying more than 11,000 scientists from around the world, clearly and unequivocally, the planet Earth is facing a climate emergency. This is a point of crisis. And it's happening on our watch. So the question is, what do we do about it? I think the first thing is we have to think about, how do we limit that, right? And so increasingly we're talking about how to try and limit global warming, stabilize the temperature of the planet, and setting a target that we have to try and meet. And so there's a sense that there's a certain amount of damage that's going to be inevitable. We're already seeing it. There's already people's lives who are being lost. So there's a sense that some of that is acceptable and then others is unacceptable. And I think there's always an ethical question about unacceptable to who, right? But the key point is that we have this choice now. We can either continue burning fossil fuels and head towards an increasingly warm and catastrophic future, or we can try and stabilize it and minimize some of that harm. And so this is actually a choice that's now going to take place over the lifetime of someone born today. Right? The next 75 years, we will know whether or not we're in that 3 degrees world, or if we manage to stabilize and limit it to 1.5 or 2 degrees. So the Paris Agreement that was signed by all world governments in 2015 had this promise: to hold global temperatures below 2 degrees, or to aim to hold it below 1.5, in recognition that that would minimize the harm that was caused to the global south countries. The key point is that the more CO2 that's emitted, the higher the concentration of greenhouse gases in the atmosphere goes, and therefore the higher the temperature of the planet goes. It's a very simple relationship. So simple, in fact, that we can plot it pretty much as a straight line. So the more CO2, the more warming. The other thing about that is that it gives us clarity. because it means that if we want to stay below 2 degrees, for example, we know how much carbon we can afford to burn and have a reasonable chance of meeting that target. That means we have a carbon budget. Now, this is the carbon budget for 2 degrees. If we'd started peaking emissions in 2011, we could have come down along that green line and had a fairly good chance of meeting 2 degrees. That would have required reducing emissions by 80% by 2050. Okay, we didn't peak emissions in 2011. So we put out more CO2 in the meantime. If we peaked them in 2015, we could have come down the blue curve. We didn't peak in 2015. If we peaked in 2020, we'd have to come down even faster along the red curve, right? The point is that it's the amount of carbon that matters, so it's the area under these curves that have to stay the same. The longer we delay, the harder the challenge gets. So the point here is that it's the cumulative emissions that matter, so it's a carbon budget that matters, which rewrites the chronology of climate change, right? This is not about long-term gradual reductions in the future. It's about urgent and radical reductions that have to happen now, today. This is widely known, and here's the Fatih Birol, the executive director of the International Energy Agency, a very conservative state organization, saying, if governments are serious about climate crisis, there can be no new investment in oil, gas, and coal from now. And he said this a few years ago. Unfortunately, we're continuing to increase production. So this is showing you this increasing gap between what governments are doing, the red line, which is taking us towards the 3-degree future, and what is needed, the blue and the green line, for 1.5 and 2 degrees Celsius, right? And so we're going to be producing twice as much fossil fuels in 2030 as will be compatible with the 1.5-degree target. And governments are increasing production all the time, right? So we've just seen in the UK, our government has announced that they're planning to expand oil and gas licensing in the North Sea. We're seeing the same being said in the US, in Canada, and so on, right? That's got to stop. And it's not like we don't have the solutions. This is the craziest thing about it, right? The IPCC are also incredibly clear in their reports on this, right? Yes, we'll need rapid and far-reaching transitions across all sectors. That's a given. But they say feasible and effective low-cost options for mitigation and adaptation are already available. And they say that we have high confidence in that, right? We know we could do that. So why aren't we? Why is it that concentrations keep rising even though we put out report after report after report? I think this paper here has a really good analysis of why, right? They ask the question, why haven't we bent the global emissions curve? And their answer is, it's to do with power, right? Political power. But political action to mitigate climate change has been slowed at the regional, national, and international levels through direct lobbying by fossil fuel companies and through funding of political actors. It's been a deliberate attempt to slow action and to delay progress. The IPCC say something similar, slightly more politely, because it has to be signed off by all the world's governments. But it says this, right? Accelerating climate mitigation includes simultaneously weakening high carbon systems and encouraging low carbon systems, and overcoming resistance to policies from incumbents in high carbon emitting industries. And to do that, we need this, and the IPCC is very clear about this as well, we need collective action, right? We need collective action as part of social or lifestyle movements to underpin system change. And that's where we all come in, right? How do we contribute and instigate that collective action? So to sum up, in the words of Antonio Guterres, the UN Secretary General again, climate activists are sometimes depicted as dangerous radicals, right? But the truly dangerous radicals are the countries that are increasing the production of fossil fuels, right? He goes on to say, we need disruption to end the destruction. And so my invitation to you this weekend is to really think about what can we do to disrupt the status quo, to challenge that power, and to bring about the rapid transformation that we so desperately need. Thank you very much.